Engineering definitions. We've been throwing around the word engineering and engineers around a lot lately, and really it applies to all these classes, whether you're in print tech, whether you're in one of the engineering classes, or even electronics and robotics. There is engineering happening, and you are being engineers as you're going through these classes, whether you realize it or not. Let's take a look at some of the definitions. First of all, what is engineering itself? Engineering basically is an application of mathematics and scientific principles to better improve life. Plain and simple, everything around us, everything you see in the room has been engineered at some point by people to make our lives better. So, you have engineers. What is an engineer? An engineer is a person who is trained and uses technological and scientific knowledge to solve practical problems. Here are a couple places you can go take a peek at examples of engineers. But essentially, it's anybody that's trained to use technology and science to make things better. So what do engineers do? Really, there's 5 main components that we're going to be looking at. Engineers will do research. Research is an important part of it. They develop. They have a process of taking something from one stage to another. They develop. They design. They create. They supervise, and they manage. So it's kind of a broad spectrum, and we're talking in broad generalities right now, but this is what engineers do in a nutshell. Research. Big part of engineering is research, and the purpose of research essentially is to employ basic scientific principles in the discovery and application of new knowledge that will have a commercial or economic value. So we're just employing what we've learned from science and technology to give things more value, whether it's commercially, privately, economically, or socioeconomically. We're improving value in some way or another. We use research to develop existing or invent new things. And we use research to discover truths about a certain subject. Research, big part of digging in and finding out what's going on. Development. Development is the actual construction, fabrication, assembly, layout, and testing of scale models, pilot models, and experimental models for pilot processes or procedures that will work. We're creating prototypes, if you will. We're building stuff. We're figuring out how stuff is going to work or interact with each other. Does not deal exclusively with new discoveries, but involves using well-known principles and employing existing processes. So it's not exclusively inventing, but it's also innovating or creating new ways to do a similar function, making it better. Development can also involve searches in a library, manufacturing, literature, and patents and existing ideas. So research turns to development. Sometimes development requires us to go back and do a little more research. Design. Design is the fun part, I think, of the engineering process. We kind of want to anticipate problems that might arise, that a user might come up against. in the application of a machine or use of a structure. We want to anticipate what might go wrong and figure out a way to make it better. We want to prevent user errors, meaning we want the people that use our products or service or process to be free of accidents and dissatisfaction. We want to make it the best experience we can. Design also requires a mastery of basic engineering principles, mathematics, and an understanding of the capabilities of machines. So you've got to know a little bit when we get into the print tech stuff, force, how levers work, how gear ratios interact with each other. All this stuff goes into that design process. Engineers also supervise. Supervisors have to take an engineer's drawings and supervise the assembly of an object when it's conceived. They work closely with technicians and mechanics and labor people. They are associated with the process of estimating and bidding on the financial side of it. They employ knowledge of structural materials, fabrication processes, and general physics principles to estimate both time and cost to accomplish a task. So what else do engineers do? There's production and construction. Like a project engineer, for instance, controls other engineers on the job. They might prepare schedules for production or construction. It also might you might have to have a working knowledge or a knowledge of engineering principles and certainly visualization skills. So you have to be able to conceptualize in your mind what needs to happen or what might be better, what's going to look aesthetically right. Those type of things are what we want to look at through the production and construction. So what kind of functions are engineering performs? They might work in an operations situation or a plant setting. They might be responsible for maintenance of the building, equipment, grounds, and utilities. Could do various routine tasks of setting up and regulating complex automated machinery. They might have a wide knowledge of several branches of engineering. They might compare costs of operating under various conditions, and so forth and so on. Evaluating, and certainly they have to be able to work with people and know the machinery, know the concepts of the machinery, and know what results to expect from that machinery and people that are working with the machinery. Sales, they might be in a situation where they're asked to present an idea to a group of people, say investors, or to a consumer population. They might be doing test marketing. They might have to go out and be familiar with a certain plant's operation and know how the process in their plant works. They might have to be able to show economic opportunities and how economics are involved and be able to convince a consumer to buy. But sales might be a part of the engineering world. Management. Recent surveys show that a trend today is for corporate leaders in the United States to have a background in engineering. So if you're wanting to be a CEO of a company one of these days, an engineering background is certainly a strong feather in your cap. Other functions might be using the capabilities of the company to the best advantage to produce a desirable product in the competitive economy. They're going to make decisions based on financial assets, labor, equipment in the plant, what tools and resources they have, so forth and so on. They got to know the business side, and they have to be concerned with long-range effects on policy. What are their decisions going to reveal down the road financially, legally, and with the personnel? And how is that going to affect any decisions made? So there's a bunch of different types of fields of engineering. We kind of think of engineers as being, I used to think of engineers as being simply structural engineers or mechanical engineers. And then I got, interested in electronical engineering, computer engineering, and there's a whole bunch of fields. So let's take a look at a couple of the fields that might be out there. Starting off around here down in Langley, aeronautical engineering is a huge field. It deals with flight and the movement of fluids in the Earth's atmosphere. This involves aerodynamics, propulsion, controls, structure. But aeronautical engineering is a huge and lucrative field to hit into. This is a little bit different than aerospace engineering. Aerospace engineering deals with environments not found on Earth. For instance, they're dealing with stuff centered on propulsion and cryogenics, materials and navigation, thermal dynamics, cosmic radiation, stuff that's not found on the Earth, if you will. Agricultural engineering blends engineering knowledge with soil systems, land management, and environmental control. Has basically 5 fields within agricultural engineering. Again, a big thing now with the green movement going on that's been going on in the last decade or so. Soil and water engineering. William & Mary has an extension down at Gloucester Point that deals with a lot with water engineering and how the oyster beds are dealing with all the environment. Food engineering, power and machinery, structures, and electric power generation. All types of agricultural engineering. Architectural engineering. That's what I used to think of as an engineer. They work with structural integrity and safety of design. Structural engineers, in this field are very similar. The main difference is the concern for aesthetics. So architectural engineering is more dealing with aesthetics. Structural engineering is dealing with the structural integrity of a building. Then there's automotive engineering. Automotive engineers design and build types of vehicles. Cars, trucks, tractors, bulldozers, motorcycles. They deal with engine design, structure design, aesthetic design, and of course, tire and wheel design. Biomedical engineering, another lucrative field. Spent some time up at UVA dealing with some of the biomedical engineering stuff. But basically, these guys are bridging engineering, physical and life sciences, and identifying and solving medical and health-related problems. There's basically 3 areas of biomedical engineering, 3 major areas: bioengineering, medical engineering, and clinical engineering. Chemical engineering. Chemical engineers apply scientifically the principles of chemistry, physics, and engineering to design and operate plants for the production of materials to undergo chemical changes during the process. They're responsible for new and improved product and processes, like new fuels for rockets, reactors, booster propulsion, medicines, vaccines, serum, plasma, plastics, synthetics, textiles. This is all falls under chemical engineering. Like architectural engineering, there's also civil engineering. Civil engineering deals with public and private sectors, the facilities like bridges, roads, tolls, tunnels. Projects vary widely in nature. Space satellites, launch facilities, offshore structures, like we said, bridges, buildings, highways, transit system, dams, airports, irrigation projects. We mentioned tunnels, treatment and distribution of facilities for water, collection and treatment for wastewater. All this falls under the civil and construction engineering. If you want to design roads, traffic patterns, and that type of thing, this goes under civil engineering. Computer engineering. Go to ODU. They have a great computer engineering department. This deals with the design and organizations of computers, both hardware and software. Got a question for you. Who is the largest consumer of computers today? Which industry uses the most computers today? It's the automotive industry. Design, CAD drawings, of course, part accounting and all the other stuff they use it for. But civil engineering civil engineering construction, but computer engineering is huge, and the automotive industry is a great place to be if you're into computer engineering. And then for electronics and robotics, and even print tech, electrical and electronic engineering deals with the motion of electrons and metals. Work here is focused on large electrical system, motors and generators, electrical circuits and buildings, power transmission systems, electrical generation plants. All this falls under electrical and electronic engineering. Even circuit boards, small micro electronics. All this falls under the electronic engineering. Then there's industrial engineering. This is the design, improvement, and installation of integrated systems of people, materials, and energy to produce a product at the lowest possible cost. This deals with design systems for the manufacture of products, including raw materials to machines, workforce to operate the machinery, removal of finished products, maintenance of machinery, and analysis of manufacturing processes. If you go down again in Gloucester, there's the Canon facility down there that is basically an industrial engineering facility, and that location there handles all of the printer cartridges recycling for the entire world. That's right, in Gloucester, that industrial facility handles all the printer cartridge recycling, and the automated system there are spectacular. And by the way, if you walk into that plant, even though it's an industrial plant, it's spotless. You could eat off the floors, it's so clean. But that's an industrial type of engineering situation. Manufacturing engineering is another area, dealing with design of manufacturing facility, possibly for a product or specific product or system. Deals with physical plant layout, use of existing machines or new machines. You might, as a manufacturing engineer, negotiate in the buying or renting of facilities, purchase of non-producing facilities and equipment. storage facilities, for instance, packaging of product, and of course shipping to market. How do they get all that stuff bottled, boxed, put together, and out to the consumer? And then the one I think of a lot with engineers is mechanical engineering. These guys apply principles of mechanics and energy to the design of machines and devices. This is most often associated with devices that move, but include thermal designs as well as HVAC. They might do vibration analysis, lubrication, gears and bearings, cams, all that good stuff is included in mechanical engineering. So these are just a few of the engineering opportunities out there, and really this is just touching the broad sense of it. If you really break it down, there's probably hundreds of fields of engineers, and we'll talk later about the income potential for some of these guys. But essentially, if you walk out of college with pretty much any engineering degree, especially a decent school like UVA or like Tech or even Old Dominion, William and Mary, one of their engineering degrees, you'll walk out of there and probably be looking at in the neighborhood of $60,000 to $80,000 to start, just to start, right out of college. And that's why it's such an appealing, that's part of why it's such an appealing field for people to want to get into. It's also a very rewarding field. You're creating things, you're designing things, you're making things better for people. So that's engineering in a nutshell. We're going to move on to some other stuff, but I wanted to just give you a broad sense of the engineering world.